Unit 2, Lesson 7. We are going to be talking about the normal model, reviewing. You already learned how to do these, but we're going to put everything together, finding the percentage given the value and finding the value given the percentage. And this is all called the activity called normal model practice. Okay, for the first part of this, we are going to look at the way that I showed you how to do it when it's asking for a value under the curve that is right smack on one of the standard deviations. So the first step you're supposed to do is you're supposed to label this of 1.84 and a standard deviation of 7. And this is seconds. It's talking about that it takes 1.84 seconds on average for a car in the Gingerman Raceway to go around the track with a standard deviation of 0.07 seconds. So I ask you to label the normal model. So the first thing to label the normal model is make sure you put N, indicating that it's normal. 1.84 is the mean, and 0.07 is the standard deviation. Great. Now you're going to see this is the mean is 1.84. The standard deviation plus 0.07 is going to get you 1.91, and so forth and so on to get the rest of the values. Subtract 0.07 to get you 1.77, and so forth and so on to get you the rest of the values. Okay, number 2 says what percentage of the lap times are less than 1.7? So 1.7 is right here, and that's 2 standard deviations lower than the mean. Remember, 2 standard deviations is 95%, and so that is going to be 2.5% on each side. That's where the 2.5% comes from. You can do Z-score chart, or you can do your calculator also on this, but it's a little bit easier just to go ahead and use your 68, 95, 99, 7. Because you don't have to do any math, it's already done. So let me just remind you what the 68, 95, 99, 7 rule means. It means exactly this. Let me just change colors. So 68 means 68% of the data exists between one standard deviation of the mean. 95 means that it exists within I didn't draw that correctly. It means it exists within 2 standard deviations of the mean. And 99.7 means that 99.7% of the data exist within 3 standard deviations of the mean. So then it says what percentage of elapsed times are greater than 1.77? 1.77 is right here. So we're just going to kind of use a little math. It wants this here, all of that. So greater than 1.77, I'm going to say, well, it doesn't want this here to the left that I'm going to just kind of shade in green. And so since this here is 68%, that there is 16%. So it wants all but 16%. So that's what I did. I did 100 minus 16 to get the 84. All right, so for the next one, it asks, just erase, get it clean. There we go. What's the percentage between 1.7 and 1.91? 1.7 is 2 standard deviations lower than the mean. 1.91 is 1 standard deviation above the mean. So I'm just going to again say, remember, that's 2.5%. And then for 1 standard deviation, that's 16%. So it's all but this area here. Again, the green area is the area it doesn't want. And it wants this, let's say, red area, which is kind of usually opposite. Usually it's the red it doesn't want. But it's the red it wants. So it's 100%. Minus, it doesn't want the 16 plus the 2.5, which gets me the 81.5. Okay, then it says what lap time would be the slowest 2.5%? Well, slowest 2.5%, you may be tempted to go down here because it's a lower number, but remember in times, you want a lower number. So slowest 2% would be 1.98. Slowest 2.5%, sorry, would be 1.98 seconds. And the reason it's 1.98 seconds is because 2.5%, remember, is the 95% is the 2 standard deviations from the mean, 1, 2, 1, 2, and that's 95% of the data, which means there's 2.5% on each side. Okay, so for the rest of them, you have to use either a Z-score chart or a calculator because it doesn't land perfectly on here. And I've got how to do the Z-score chart here, and I'm going to just write the calculator commands for you so you can follow on the calculator if you prefer. So to do this, the first step is to draw a picture. Make sure you please do that. So in order to beat his friend, Mr. Wilcock needs to have lap times that are less than 1.72 minutes. Find the proportion of laps that were less than 1.72 minutes. Proportion's just another way of saying what's the percent. So I'm going to, first of all, first step, draw it, and I have my normal model shaded, my mean and standard deviation. Second step, let's do our z-score, which is observed minus mean divided by standard deviation. Observed was 1.72 minus mean divided by standard deviation, and I get negative 1.71. I would then look this up in my z-score chart. I would look at negative 1.7, and this is 0, and this is 0.01, like that. And I would get 0.0436 is where that would be in my z-score chart. Or I would go to normal CDF on my calculator, which remember is menu, stats, distribution. And my lower bound is going to be the most left area that's shaded, which is off the chart. So we're going to call that negative infinity. And on your calculator, you have to put negative 9999. And then upper bound is the most right area it's shaded, which is 1.72. And the mean is 1.84. And my standard deviation is 0.07. And you are going to come up with the same answer. Okay, for the next one, we're looking for the middle. So the first step is we're going to draw a picture. And I have a picture that represents that I'm looking for the area between 1.75 seconds and 1.85 seconds. So second step, I'm going to find my z-scores. So I found a z-score of negative 1.29 and a z-score of 0.014. So I'm going to look up my z-score at negative 1.29. And then I'm going to look up and that one I get 0.0985. And then I'm going to look up my z-score of 0.104, and I'm going to get a z-score of 0.5557. I'm going to subtract the two, and I'm going to get about 45%. If I did this in my normal CDF, my lower bound would be 1.75. My upper bound would be the rightmost shaded at 1.85. My mean and standard deviation are the same thing that we had before of 1.84 and 0.07. For the next one, it asks for more than 2 minutes, so I have this shaded on the right-hand side. And first step, draw my picture, write my normal model, mean and standard deviation. Second step, let's write our z-score out, and I get my z-score, and I get 2 minus 1.84 equals over 1.07 this is my z-score here. So if I look that up in my z-score table, I've got 2.2 and then 0.09, and I'm going to find what that is, and that is going to be 0.989. But that represents 98.9% is this part. I'm looking for the other part, so that's why I subtract it from 1 or 100% to get 0.011 or 1.1%. You could, obviously, all these guys, this is 45.72%. You could call it in a percentage or in a proportion. If I did normal CDF, my lower bound would be the 2. My upper bound is going to be off the chart at 9999 because it keeps getting shaded to the right. My mean, of course, is 1.84, and my standard deviation is 0.07. And I would get the same answer, or something really similar that would allow you to, that would be fine. Okay, so then this one, what is the lap time necessary for Mr. Wilcox to be the fastest 3%? So the fastest 3% is the lowest lap time, because I want it to be on the area. And so this here is going to give me the area 0.03. So the first step we're going to draw. The second step here, I'm going to look for the area 0.03 in the chart, and I'm going to look for my z-score. And I do look for my z-score. In fact, I get a negative 1.8.08. So I get a negative 1.88 z-score. Then I'm going to go ahead and do this. It explains it, but I'm going to show you how to do it. I put z-score equals observed, negative 1.88, minus that's equal to negative 1.88, and that's equal to my mean, or my observed, which I don't know my observed, so I'm going to put y, minus my mean, 1.84, divided by standard deviation of 0.07. At that point, I'm going to multiply negative 1.88 times 0.07, and then, of course, we're going to add the 1.84, and that's going to get me my y, which is right here, and I get 1.7084. If I were doing it on the calculator, this one have to use inverse norm, and the area is just 0.03. The mean here is 1.84, and the standard deviation is 0.07, and it would also get me 1.704. This one just says redo the questions, and we're going to use a calculator this time. It used an applet, but I used a calculator on all of these, and you're going to see that the values are very, very close. Okay, thank you very much for viewing. If you have any other questions, please let me know.